Gentlemen, welcome back to the shop today. The Milwaukee half-inch impact gun. That's no verky. Now this thing I got from the Getting Spot on account of it being in the scrap bin. About a year old, maybe a year and a half old. Probably got conservatively 300 hours on it. At the outset, maybe 200 hours of rattle gun service. And now, I thought I fixed it. And of course, it's got the toughest problem to troubleshoot, an intermittent problem. So I pulled the old Fonzarelli on it. Sometimes it would work, sometimes it wouldn't. And now it doesn't want to work. So what I did is I just cleaned up these leads, and then I crimped them a little bit to try and make better contact. I figured that's what the problem was. But now she's completely dickered. We'll just do the idiot check there. Yeah, she's completely dickered. Lots of fun at Finnegan's Wake. So we'll have a look at her. Well, we'll just make sure she's completely dead, yeah. Still, any excuse to have a peek under the skirts, what? We'll see what makes her chooch. Hopefully we'll find what killed her. Now this gun here is not what you call a real heavy hitter, but convenient. Not nearly as torquey as an air tool pneumatic rattle gun, however, quite a bit more convenient because you don't need any compressed hair. On the subject of rattle guns, did a test there, just off the cuff on FAP-OFF, the best, I think it's almost 750 bucks now, half-inch drive FAP-OFF versus Nitro Cat from Mac. That $700 gun, not even close to the Nitro Cat. Not even close. I would like to get my hands on one of them earthquake guns from the Hazard Fraught, but I haven't been down to the States in a while. Okay, we're in. Just boot. We're in, as we can see, industrial environment, lots of dust. Abrasive dust. Definitely wasn't used in a dentist's office. Try and move that around. Hit a different spot on the commutator. Ooh. Ooh. Oh. Oh my. Something wrong there. Something desperately wrong there. Alright, it's actually stiff on account of me being thick. Because the bearings aren't indexed anywhere. These are permanent magnets. It just pulls the armature over. Like so. So we check the bearings. Little flop, a little bit of slop in this front one, but you got to put pressure on it, of course, to actually feel if it's good or bad. And that one seems okay. This back one, little baby one, oh, it's fine as well. So just a matter of, I don't see any burn spots here. We'll take it right out, but we'll have a look for burn spots. I don't smell any of the stank, so we should be good that way. Now the brushes, this has been well used. The brushes have about half their life left in them. At the very least, we don't have ourselves a crib death situation, so that's out. Nice. Here's the windings here. See all sorts of abrasive particles, magnetic particles in there. Lots of goo. We'll try and clean that up as best we can. Okay, here's the field. Epoxied in, neodymium magnets, I believe. Yeah, they're epoxied in. Nice, big, beefy steel tubular cross section, and then not hot dip galvanized, but electroplated galvanized. And you can see where it's been fretting up against the plastic of the tool body. So that plastic must be fairly skookum. Would have to have some glass fiber reinforcing. Not a bad little part there. We got the motor rotor. Oh, this is odd. A sealed bearing, 625 RS. So that'd be the 5. That'd be 5 millimeters on the ID. Maybe, I don't know, 15, probably 16 millimeters on the OD. And we have not a 608. No, not a skateboard bearing. A 609. Z shielded, of course. And it is an Outdo brand. Do something. 609Z, so that's 300 for the 608, 300 pounds static for the 608, so this would be, I don't know, 640 or something like that, or 340 rather. You can start to see some delamination here in the silicon steel core laminations. Not a bad little winding here, but balanced not by grinding this off, but just with shmoo. And where it terminates at the bus bar, at the commutator bar, nice and beefy. That's a nice big beefy wire there too. Got to be, oh, at least it's probably 18 gauge. I'll measure it here. I find it a good spot to bite is sometimes troublesome. 35 thou. That's metric. Oh no, my mistake. 20 American wire gauge. Still, plenty beefy. Wait a second, there's no fan on this armature. What the fuck over? No cooling? Why do they even have slots in the outside of the case? There's no airflow. That's bizarre. And here we got the input gear, input pinion, helical cut. You can see it was machined from a solid piece. It was not powder or metallurgy. And starting to see some wear here. Razor sharp and some chunks. She's getting a little bit chewy here on the very tippy top. Still, nothing a little grease can't fix. So that is not our problem. Nicely machined. You can see the difference. They don't bother in grinding all the way down. You see the hobbing tool marks down further in the root, and then this was ground, and this would be, there's a hole there, but this would be shrunk, heat shrunk on, so there'd be an interference fit there. You'd heat this up and slide it onto this guy and it would never come off. It's kind of shitty for guys like us, because what are you going to do with that bearing craps out? I guess you got to replace the, chances are, this bearing still seems okay, a little bit weeble wobbly, but this is starting to get chunks out of it, so this might fail before anything else, in which case you got to replace the whole rotor anyway. And then the brush holder, just plastique, nothing special here. PA66. Oh, it's 50% glass fiber reinforced. And it's got brass throughout. And nice screw-ons here, and the brushes themselves. They have the braided copper impregnated right into the brush. Nice brushes. They're tiny, of course, but they have to fit the size of the commutator. They are starting to get some wear though. Not much, not that. If I had brushes here, if I could get them quick, I'd change these. Good tension on the springs though, so the pixie transfer from brush to commutator is not the problemo. Got the trusty DMM out. We'll put the battery in. Try not to light the place on fire. See what is going to the brushes here. Pull the trigger. 20 volts. Huh. Maybe it is a problem with the brushes. When I first looked at this, I figured, okay, well, it's got a whole bunch of electronical doodads. Obviously, the electronics is what shit the bed, son of a diddly. And with it being intermittent, you know, it might be a wire or something in there. But I think it's the brushes now. The thing is, I like using this one better than the DeWalt, the old DeWalt that I got, nickel cadmium batteries, because this one throttles. This guy is either off or on, which has its advantages. It's more robust. There's no electronics that are going to crap out, but it is really convenient to be able just to give her a little rattle instead of giving her full bore all the time. My 18 volt batteries are all crapping out, so I bought this here thing. Little adapter, and it looks looks like a backstreet abortion, but it actually works good. I mean, it ain't pretty. She got it where it counts. Wee bit of a problem upon further casual observation You gotta buy the whole back assembly. You can't just buy the brushes on account of these being staked right in. The pigtails on the brush being staked right into this part here. So what I'm going to do is continue with the teardown, and we'll get her back together and get some parts all in order, and I'll just have to take it back apart. No big deal. And now we're getting into the business end. This is beefy, heavy. We got a rubber bumper. Oh yeah, in the case here. This is TPS Sebs, so that butylene with the styrene on the end of the molecule, that's what for gripping, and PA6 glass fiber 30%. Pretty much bog standard for good tools, ABS standard for craptacular tools. And this has a Boone condom on there. Looks like it's mainly for vibration damping, but also keep the shmoo out of the mechanism. Nice little aluminum cover. Nice big deep ball groove ball bearing. China Pier. And it is a, can't read it. It's oh, 1603 inch. Take that, metric fanboys. That's a oddly enough, that doesn't have much of a static load rating on it, maybe 300 or 400, but it is an inch bearing, 7/8, something like that. Ever onward. Ay ay. Notice how I gleaned over the stuff that I can't remember. Here's a nice part, powdered metal. Or it might be yeah, no, it's got a lip there, so it's complex enough to be metal injection molded. It essentially the same process as plastic injection molding, except it goes through a green oven first to bake off all the shmoo. It shrinks, and then it goes into a hotter oven to get the grains to grow together. You see it's lapped on both ends. It's lapped on the front end anyway. Very smooth there. Should probably keep track of how that goes together. I haven't had good luck lately with getting shit back together in one piece. That's mainly because we're talking about batteries. Batteries don't take well to being hacksawed. That over there so we can lose it. That is a nice big heavy hammer. And here's the anvil. Look at this anvil. It's got some smearing at the top, but that's part of the mechanism. The mechanism, this guy, has to pop up and over against this heavy spring tension. That's what gives you the impetus. But if you look at this, the foundry marks, or rather the forging marks, barely even worn off the thing. So this is definitely a long life item here. Let's see how this thing works. Okay, the motor rotor engages, or rather is the sun of this planetary gear set. 3 planets in the ring. Now the ring, as you can see by the dogs on it, is stationary. That means that the carrier that the planets are on is what's spinning a thing. So we have the motor spinning these guys. These guys spin, this can't spin, that means the carrier has to spin. So this whole thing is attached to the carrier, and this whole thing is what's spinning. Now, big heavy spring on here. This can move backwards, and I can't actuate that. Not even close. So that is a heavy, heavy spring. What happens is this thing hits and bounces up and over the anvil. In order to do that, it has to depress that spring. And as we can see here, we've got some ball bearings in there and some slides for that to press and rotate down. So that's what's happening. When it hits, it goes up and over the anvil and then continues gets some more momentum and then slams into the anvil and up and over. And that's what we can see here in the hammering and then the subsequent scouring of the two metals. So it's pretty critical that this be well lubricated. So I'm going to go and, as you can see, pretty nasty schmoo in there. We'll clean all that up, change the grease out, put maybe a rock drill grease, or that might be too heavy. This is one of the few cases where a little dab will do ya and a big gob will screw you. So the bigger the gob, the not better the job in this case, because if this thing hydraulics and gets packed right full of grease, it's not going to work properly. The grease needs to have somewhere to go, and if this mechanism is right loaded full of grease, it's not going to hit as hard as if it's just lightly greased. These parts are really nice, heavy, beefy, forged. Even the carrier, it's been nicely machined, is forged, has some forging marks here, and then rattled around and finished in some abrasive media to clean it up. Nothing wrong with that at all. Heavy as well. As you can see here, there's no hammers that fly out, so it's not that type of mechanism. So there's no bias for forward and reverse. There's no difference in forward torque and reverse torque because, well, you can see here the two slots that it either goes up or up the one side or the other side where the ball bearing is. They're exactly the same. Everything is the same forward and reverse. So that's what tells me that there's no bias, there's no extra oomph in reverse. Some guns give you extra oomph in reverse, but the mechanism here is not built for that. Now here's the housing, nice little roller bearing in there, just a little guy. Where are we? Hey, you framing, you fuck. As you can see though, the grease, it's not shot, it's not cooked, but it is fairly dirty, and while we're in here, we might as well change it out. Getting it back together, here's the anvil. We can see where the abrasive environment has been wearing away at the anvil. So that's what happens even if you have a soft bushing. The abrasive particles embed in the soft bushing and then work just like sandpaper. So we can see it is wearing away there. As far as grease, I'm sure Milwaukee will sell you some special formulation, you know, because I'm sure they make their own grease. But this stuff is good to 350 degrees Frankenstein, 177 degrees science. So it should be good. This is the stuff, who is this? Bought this a long time ago. The guys at General Dynamics, Bath Iron Works, tested this out, and this was the best stuff they could find. So good enough for them. The criteria for the testing was they put it on the prow of a boat and see what lasted the longest in the water spray, and this is what lasted the longest, so should be good. And an impact gun though. However, my main criteria for good grease, just like shit on a blanket. As long as it gets everywhere, you're good to go. Not that shit on a blanket is a good thing, but when it does get on a blanket, it goes fucking everywhere. We'll just pack that bearing. Now, how do you pack a bearing that you don't take off? Well, essentially, you just squeeze it in there until it comes out the back side, and then you know it's packed. I've never used a bearing packer. Actually, my papa taught me how to do this. Now we gotta spin a thing this to get that to engage. There we go. Finette your matante. Now, word to the wise, there's guys, super keeners, you know, that re-grease their gun every year, and they know exactly how much torque it puts out, and they put the torque, you know, I can feel it. But the thing is, when you take apart the gun and you re-grease it, it's not going to hit as hard until it works all that grease out of all its little nooks and crannies. So be aware, a brand new gun is not, or a brand newly serviced gun is not going to hit as hard as a gun that's got all the goop shot out of it. Now we had our A part and had a good look at her. Surprisingly, there's nothing really chintzy about this. There's a prosumer tool. It's reasonably skookum, and the hammer mechanism, I mean, heavy, nice and beefy, so probably hits pretty hard considering it is, you know, an electric rattle gun. But a little thing here on the Marquardt switch, nice name brand switch, nice big copper heatsink, that's great. But crappy little flat flex cable in here going to the sense lines for the battery that's over temp, and ground, and there's something else. Maybe a couple of thermistors, or maybe there's an overcurrent sense. Other than that though, yeah, I don't see anything really chintzy. I mean, tracking you from satellite, but what are you gonna do? Everybody does it. Fuck's your problem now? Come on. See this little slot here? It goes to the front. That's the thing. You take stuff apart. If you think about it logically, you take your time. It only really goes together one or two ways, and you can just think it out. You know, like, how do I get this back together? Well, I saw that there was a flat lap surface on the outside ring gear, and then that has to index with a flat lap surface somewhere else. So you just look for the shiny bits, and the shiny bits go together. You know, the dull bits go together, and the pokey bits go in the pokey bit receptacle. That's how you, there's nothing new under the sun. So just remember, it's all Lego. If you don't get intimidated by it, chances are you'll be able to get it back together, at least on the third or fourth try. What is the major malfunction now, you son of a bitch? Aha! A clue! No doubt, in the commentating section, we will trip out some purists who ask why I don't clean the ever-living fuck right out of this. 1, because it's a used tool, and 2, it's gonna get dirty again, and 3, check it out. We can see exactly where it's hitting. Shiny spot? Shiny spot. Huh? Stupid like a fox. Okay, this has stung me many times. So many times, in fact, that I remember not to do this anymore. Before you get her fully enrobed, make sure that the forward reverse slide switch is engaged. I don't know how many times that's fucked me over. Lots. Because this is an impact, the other thing that's kind of neat we can do is we can drive it in reverse and chewy. Oh yeah, something wrong there. We're about to actuate the impact. It's coming up off the ridge and pops back down. Whereas this one might have a different mechanism. No, same mechanism. Turns nice. That's not good. Alright, I hope you're not holding your breath, because I ain't. That chewy motor is something else. Contact. Fucking piece of shit. Fuck. Okay, well, off to the parts cannon. Ah, you picked a fine time to leave me loose wheel. Oh. And hammer we trust. Oh, those are some stinky brushes. That's kind of an odd hammering. I wonder why it would do that. One direction, not the other. Likely, because one of the bearings is acting like a sprag clutch, a one-way bearing, and kind of sticking. Those bearings were... Yeah, I'm thinking that the location isn't correctamundo, so we'll go over to the gargler, see how much some parts are going to cost to see if it's worth fixing. Alright, yeah, shitty tags. Don't even know what the fuck this thing is. Oh, we got the dick in the vice, and what with the proof being in the pudding, you might as well do endurance test this, so if it does last, it'll take us completely by surprise and wreck our day when it does crap out. Oh, you fucking son of a... But it's all junk when it's broke down. There. That'll make for a fun day. Get on you old gargler with the jazz hands routine, and once again the hive mind provides will fuck ye literally $27 for what? For the grease. Type J grease for this thing. 27 doll hairs, and that ain't Canadian pesos, that's real freedom bucks. The brush assembly, $8, no big deal. Could buy that. The armature with the bearings, 25, $30. So landed all. Oh, the switch. Oh my God! If that switch ever goes, you might as well throw the fucking thing out. $50. Okay, so I'm probably in this for zero doll hairs, and if I want to throw $50 at it, I could. But the thing is, in the tradition of 6,000 years of hard rock miners, we're gonna run her till she fucking blows. This thing doesn't owe me anything. I got her for free, so I ain't plunking $50 into her. But it might make the shift. Might last another year. Might last another 10. Who knows? You know, my baby soft hands. Hey, thanks for watching. Keep your dick in a vice. I sat and had a stink about this. I do most of my thinking in my head, and it didn't make a sense that there were no fan vanes on here. What for cooling? Sure enough, get on the gargler, recheck, and make a list of all the parts I need. Sure enough, that armature does have a fan on it. However, these ones plumb sheared right off. Not Milwaukee's fault. However, I think, well, you can tell she's loose in the hips. Now, those bearings they chose, Yulong Ding Dong brand or Dog Doo Doo brand, whatever the brand was, pretty chintzy bearings. However, it's easy to point a finger at the stinky kid in the Velcro sneakers. I think mainly the problem was that abrasive dust. Wore those bearings right out. If it was an SKF, it'd still be worn out. But here's the thing. 100 Freedom doll hairs for the parts landed to fix this thing. Now, I'm into it for zero doll hairs. I ain't touching her. I mean, she's running now, right? Good enough for eBay. I wouldn't do that on account of I've done that too, and it fucking sucks when you get a dud. So I wouldn't do that, but we'll run her till she blows. And thinking about it, those tiny little brushes, they look like they got some meat left to her, but if you see, they're extended out of the holder and they're cocked over, and actually the wear pattern on them is real funny. So super suspect there as well. Those definitely need to be changed. And while I'm in there again, I would change the bearings. However, I ain't going in there again.